Okay. Hi everyone. So, is it audible here? Is it audible? Let me know, is the video and audio are clear? Yes or no here? Audio and video clear? Good evening to all. Is audio and video clear? Let me know so that we can start the lecture. Yes? Okay. Okay. So, in the previous session here, we have started basics of vectors, and we have seen how to add the vector quantities, and also we have seen how to determine the component of one vector along the other, and also we have seen how to determine this dot product and all, and what is its significance, and we have solved some problems on work done. Yes or no? Okay. So all these things we have seen. So now today, in today's session, I'm going to start coordinate systems here. I'm going to start coordinate systems. Before that, we will see cross product also. We have seen dot product. So next we are going to see cross product. Once we complete this cross product, then we are going to start coordinate system here. Okay? Okay, yeah. So next, so we'll start cross product here. We'll see cross product. Okay. So what is cross product here? We know that A bar cross B bar, A bar cross B bar is equal to what? Magnitude of A bar multiplied by magnitude of B bar multiplied by sine theta an cap, sine theta an cap. So the resultant of cross product, is nothing but what? Is nothing but a vector quantity. The resultant of cross product is nothing but a vector quantity. Understood? Now here AB sine theta will represent the magnitude of the cross product, and an cap will give you the direction of the cross product here. Okay. See, mathematical procedures you are very much familiar here. Yes or no? Mathematical procedures you are very much familiar. So in this subject we have to study the interpretations of these mathematical operations. That is very much important in order to understand this subject here. Okay. Okay. So now we will see what actually this cross product mean. So what is its interpretation? Okay. So that's what we are going to analyze now. Okay. Okay. Yeah. Now see here. Now let us consider this is vector A bar. Now here I am considering this vector is nothing but B bar. Now always you have to consider what here? Always you have to consider theta as what? Theta is the least possible angle between A bar and B bar. Least possible angle between A bar and B bar. So you have to consider this angle here. So this angle is the least possible angle between A bar and B bar. Understood? Okay. So now here, whenever you are doing the cross product, what you are doing here? You are multiplying A. Yes or no? You are multiplying A with what? With B sine theta. You are multiplying A with B sine theta. Yes or no? Now here, what is this B sine theta here? What is this B sine theta? See, if you try to determine the component of B bar along A bar, that the component of B bar along A bar is nothing but B cos theta. Now here, what is this B sin theta? B sin theta is nothing but the component of B bar. The component of B bar that is perpendicular to what? That is perpendicular to A bar. Yes or no here? B sin theta is nothing but the component of B bar that is perpendicular to what? That is perpendicular to A bar. Yes or no? Okay. So if you draw a line here, that is perpendicular to what? That is perpendicular to A bar. Now you can determine the component of B bar, along this vertical line. So the distance from here to here, is nothing but what here? Is nothing but B sin theta. Yes or no? So B sin, you are multiplying B sin theta with A. Yes or no? So B sin theta is the component of B bar that is perpendicular to what? That is perpendicular to A bar. Understood? So that means if I represent this, I can represent this in this manner. So here B sin theta. So here you are having B sin theta. Yes or no? So this component is nothing but B sin theta. So this is A. Okay. So the magnitude of A bar I am drawing here. So this is A. Understood? Now you are multiplying A into B sin theta. Understood here? The distance from here to here is nothing but B sin theta. Yes or no? So this is B sin theta is nothing but the component of B bar that is perpendicular to what? That is perpendicular to A bar. Understood? Now here you are multiplying this B sin theta with A. So if you multiply this B sin theta with A here, if you multiply this B sin theta with A, what you are going to get? Tell me what you are going to get here. Tell me here. If you multiply this B sin theta with A, what you are going to get? What you are going to get here? See, it is just like what? Length into breadth or not? Yes or no? So if you multiply these two, what you are going to get? You are going to get the surface area or not? Yes or no? Yeah? You are going to get the surface area. Understood? So that means whenever you are doing the cross product here, whenever you are doing the cross product, what you are getting? You are getting the surface area formed by what? Formed by A bar and B bar. A bar and B bar. So that means I can say cross product will give you what here? Will give you, whenever you are doing the cross product between two vectors, then it is going to give you what? It is going to give you the surface area. It is going to give you the surface area formed by what? Formed by A bar and B bar. Formed by A bar and B bar. Okay, is it clear here? Is it clear? Now see here. Now if suppose if I move this B bar here, if I move this B bar, okay, further away from A bar, so let us consider I am moving this B bar to this location here, to this location. Now here, this angle here, this angle, I am considering this angle as theta 1. Now here, theta 1 is greater than what? Theta 1 is greater than theta. So this angle is theta 1. So now I am considering this as what? B bar. Understood? Now in this case, what is its component? Component perpendicular to A bar here. So if you drop the normal from the head of B bar onto this line, the distance from here to here is nothing but what? Is nothing but B sin theta 1. B sin theta 1. Yes or no here? Where theta 1 is greater than what? Greater than theta. Now here, if I try to multiply B sin theta 1 into A, what you are going to get? You are going to get, so now the component of B bar that is perpendicular to A bar is increasing or not? Yes or no? So this is B sin theta 1 and this is A. This is A. Okay. So you are going to get this surface area. This surface area. Understood? Okay. So that means as this B bar moves further and further away from A bar, okay, so the surface area formed by these two vectors are increasing. Yes or no? Now similarly, if I consider B bar here, let us assume B bar is moving towards what? Towards A bar. B bar is moving towards A bar. Understood? Now here the angle, let us consider this angle is theta 2. This angle is theta 2. So now what is the component of B bar that is perpendicular to A bar here in this case? So just drop a normal from the head of B bar onto what? Onto this axis. Now the distance from here to here, is nothing but what? B sin theta 2. B sin theta 2. Now here theta 2 is less than what? Theta 2 is less than theta. Understood? Now this is B sin theta 2 and this is A. Now in this case, if I draw the surface, what you are going to get? This is B sin theta 2 and this is A. This is A. Okay. So if you multiply these two, you are going to get what? You are going to get this surface area. So from this what we can observe here? What we are observing? As B bar moves towards A bar, the surface area formed by A bar and B bar is decreasing. Yes or no here? As you move away from A bar, okay, if B bar moves away from A bar, then the surface area formed by A bar and B bar is increasing. Yes or no here? Okay, so if you vary the angle here, if you vary the angle theta from 0 degrees to 90 degrees here, 0 degrees to 90 degrees. If you vary the angle theta from 0 degrees to 90 degrees, what happens to the surface area here? What happens to the surface area? Surface area will gradually increase or not? Whenever it is 0 degrees, what happens? What do you mean by 0 degrees? Both A bar and B bar, if both A bar and B bar are lying in the same direction. In this case, theta is equal to what? Theta is equal to 0 degrees. See, if you are having the two lines, if you are having the two lines in the two vectors in the same direction here, in that case you cannot form what? You cannot form any surface area, right? Yes or no? So now in this case the surface area formed by A bar and B bar is 0. Understood? Now as this B bar moves away from A bar, the surface area formed by A bar and B bar will gradually increase, and when it will be maximum here? When it will be maximum? Whenever theta reaches to what? Whenever theta reaches to 90 degrees. Yes or no? What happens when theta becomes 90 degrees here? What happens when theta becomes 90 degrees? See, this is A bar, okay, so this is B bar. If I consider this as B bar, now this angle is what? This angle is 90 degrees. Now the total B bar is perpendicular to what? Is perpendicular to A bar. Now in this case you are going to get the surface area. The total B bar is along the total B bar is perpendicular to what? Is perpendicular to A. In this case you are going to get what? The maximum surface area. The maximum surface area. Understood? Okay. So as this B bar moves towards A bar, then the surface area is going to decrease. As this B bar moves away from A bar, the surface area is going to increase. So as you vary the angle theta from 0 to 90 degrees, the surface area formed by A bar and B bar will gradually increase, and whenever it is 0 degrees, the surface area will become 0, and whenever it reaches 90 degrees, the surface area formed will be maximum. Understood? Okay. Understood here? Understood? Is it clear? Tell me here. Okay. So A bar cross B bar is equal to AB sin theta AN cap. So we have seen that AB sin theta is the magnitude of the cross product. It represents the surface area formed by A bar and B bar. When theta equal to 0, the surface area will become 0 because both A bar and B bar will point in the same direction. If both the vectors pointing in the same direction, then you cannot form any surface area. Now as this B bar moves away from A bar, the surface area will gradually increase, and whenever theta equal to 90 degrees, the surface area will become maximum. Understood? Okay. These things you have to understood here. Now here, what is this AN cap here? What is this AN cap? So AN cap is the unit normal here. AN cap is the unit normal drawn to the surface. Unit normal drawn to the surface, formed by A bar and B bar. Unit normal drawn to the surface formed by A bar and B bar. So this is the magnitude of the surface, and AN cap will give you the direction of the surface. Now what is the direction of the surface here? The direction of the surface is given by the unit normal drawn to the surface formed by A bar and B bar. Understood? So that means if you are having here, this is A bar, okay, so this is B bar. Now this is nothing but B sin theta, okay, so now this is B sin theta, and this is A, and this is B sin theta. So if you multiply these two, you are going to get this surface area. Understood? Now the direction of the surface is given by what here? Is given by the unit normal drawn to that surface. Now how many ways you can draw the unit normal to this surface here? How many ways you can draw the unit normal to this surface? In two ways or not? Yes or no? You can draw the unit normal to this surface either out of the board, or you can draw it into the board. Yes or no here? You can draw the unit normal to this surface in two ways. One is out of the board, or another one is into the board. Now which direction you have to choose? Whether you have to choose AN cap as out of the board, or we have to choose AN cap as into the board. Which one you have to choose? Understood? Now in this case, in this it depends upon the direction of A n cap will depends upon how you are enclosing the surface, that means here you are doing what here, you are doing A bar cross B bar here, you are doing A bar cross B bar. So that means you have to enclose the surface, from where to where, from A to B, understood? Okay, so the direction of the surface is given by the right hand here, rule. So what you have to do is, here we are doing A bar cross B bar. So take your right hand here, okay, take your right hand. So this point all these 4 fingers along what, along A bar. So you are enclosing the surface, you have to enclose the surface from where to where, from A bar to B bar. So curl your 4 fingers here, from A bar to B bar here, then the thumb is going to give you the direction of what, the direction of the surface. Understood? So now here, since you are doing A bar cross B bar, you are enclosing the surface from A to B, and hence the thumb is going to give you the direction of the surface. The direction of the surface in this case is, it is pointing out of the board. Now if you do B bar cross A bar here, the magnitude of the surface area is not going to change. Yes or no? The magnitude of A bar cross B bar is same as what? Magnitude of B bar cross A bar. But if you do A bar cross B bar is not equal to what? Is not equal to B bar cross A bar. Why here? Why it is not equal to B bar cross A bar? So whenever you are doing B bar cross A bar, okay, so that means you have to enclose the surface from where to where here? From B to A. So take your right hand 4 fingers, okay, so point along B bar. Now curl your fingers from B to A, then thumb is pointing into the board, yes or no? Okay, so that means the direction of this surface you have to consider as what? Into the board. Understood? So direction wise both are opposite to one another, magnitude wise both are same. Understood? Okay. Is it clear here? Is it clear what cross product represents? Is it clear here? Yes or no? Okay. So A bar cross B bar is not equal to B bar cross A bar, because direction wise both are what? Both are opposite. Understood? Magnitude wise both are same. So from here onwards we are going to consider the surface area as what? Surface area is a vector quantity. Whose direction is given by what? Is given by the unit normal. Drawn to that surface. Understood? Okay. So you can draw the unit normal in 2 ways. One is out of the surface or into the surface. So in which direction you have to choose will depends upon what? Will depends upon how you are enclosing the surface. Understood? Okay. So these points are very, very important here. Okay. Now one more point I want to explain here. See, now if you consider a open surface here, okay, see what is the difference? Between open surface and closed surface here? See here, open surface is always enclosed by a closed loop here. If this surface is enclosed by what? Enclosed by this closed loop. So this is the boundary of this surface. Understood? So this surface we call it as what here? We call it as open surface. Understood? So if you are having a open surface here, like this, understood? Okay. So this surface is going to have 2 directions here. It can be either out of the board or into the board, depending upon how you are enclosing this surface. If you enclose the surface in anti-clockwise direction, then the direction of the surface you have to take out of the board. If you enclose the surface in clockwise direction, you have to consider the direction into the board. Okay, so it depends upon how you are enclosing the surface. Understood? Now I am talking about another surface here, that is closed surface. So we will see what do you mean by closed surface here? See, closed surface means, if I consider this classroom here, okay, so the classroom is nothing but what? A closed surface or not? Yes or no here? See, I am drawing here closed surface here. See, closed surface means what? Closed surface will always encloses what here? closed surface will always encloses what? See, this is the closed surface here. Okay, so this is the closed surface. This closed surface is enclosing what? Is enclosing what? It is enclosing some volume or not? Yes or no here? Okay, so closed surface will always encloses what? It always encloses the volume. It always encloses the volume. Yes or no here? So a closed surface will always enclose some volume. Understood? Whereas open surface is bounded by what? Is bounded by a loop. It is bounded by a loop. Here volume is bounded by a closed surface. Volume is bounded by a closed surface, whereas here this open surface is bounded by this loop here. Bounded by this loop. So that is the difference between open surface and closed surface. Okay, so the direction of the open surface can be plus or minus an cap, plus or minus an cap. That means it may be either out of the board or into the board depending upon how you are enclosing the surface. Understood? But for closed surface here, if you are considering the closed surface, then always the direction of the closed surface here, the direction of the closed surface is uniquely defined here, So it is always given by the outward unit normal. It is always given by what here? The outward unit normal drawn to the surface. Understood? For open surface, it may be outward unit normal or inward unit normal depending upon how you are enclosing the surface. But for a closed surface, the direction of the closed surface is uniquely defined, which is given by the outward unit normal. Always you have to represent the direction of a closed surface always as what? Always by outward unit normal drawn to that surface. Understood? Okay, so that means if I consider this closed surface, so this is the direction of the closed surface, this is the direction of the closed surface, this is the direction of the closed surface, this is the direction of the closed surface. Understood? Always you have to draw what? Outward unit normal. Understood? Okay, so that is the difference between open surface and closed surface. Understood? So have you understood here clearly about surfaces and directions and everything? Is it clear? Yes or no here? Please do some comments here so that I will know whether you are understanding or not. Is it clear? See, mathematical procedures you know here, mathematical procedures already you know, okay. So we have to see its interpretations here. That's what most important in this subject, okay. Okay, okay. So now, we will solve one problem here. So example, let us take one example. Now A bar is equal to 2ax cap plus 3ay cap plus 4az cap. Okay, 2ax cap plus 3ay cap plus 4az cap. And B bar is equal to, let us say, 1ax cap plus 1ay cap plus 1az cap, okay. So then determine the direction of the surface, determine the direction of the surface, then determine the direction of the surface formed by A bar and B bar, okay. So assume surface is enclosed from A bar to B bar, okay. So assume surface is enclosed from A bar to B bar. So that means what here? What you have to determine? They have given A bar, they have given B bar, and they are asking to determine the direction of the surface here. The direction of the surface formed by A bar and B bar. Direction of the surface formed by A bar and B bar. So whenever you are having two vectors here, okay. So if you do the cross product, you are going to get the surface area. Yes or no? Okay, and if you want the direction, you have to determine what? Unit normal. Yes or no? Okay, so we know that A bar cross B bar will give you what? Will give you the direction of the surface. Understood? So A bar cross B bar is equal to what here? Is equal to magnitude of A bar multiplied by magnitude of, wait here, wait. I can write in this manner, see here. Okay. Now here I can write this as magnitude of what? Magnitude of A bar cross B bar. This is the surface area magnitude multiplied by what? Multiplied by direction of the surface. Understood? Now what is the direction here? Tell me. Now what is the direction of the surface? How to determine? A n cap is equal to what? Is equal to A bar cross B bar. Divided by what? Divided by magnitude of A bar cross B bar. So this is going to give you the direction of the surface. Yes or no? Here I have said that assume the surface is enclosed from A bar to B bar. That means you have to determine A bar cross B bar. Understood? Okay. Since they are asking only direction here, you have to determine A n cap. Yes or no? Okay. Okay. Now I hope you know how to determine this A bar cross B bar and all here. Yes or no? See. Okay. So A bar cross B bar here, A bar cross B bar is equal to what? Is equal to, so here AX cap, AY cap, you know this determinant form, I hope. Okay, so it is very simple here. Okay, now here in the first row write the coefficients of X component, Y component and Z component here. Write the coefficients of X component, Y component and Z component, that is 2, 3, 4. And for B bar, write the coefficients of X component, Y component and Z component, that is 1, 1, 1. So what you are going to get, tell me? So AX cap into 3 minus 4, that is minus 1, minus AY cap into 2 minus 4, that is minus 2, plus AZ cap into 2 minus 3, that is minus 1. Okay, so what you got here? Minus AX cap plus 2 AY cap minus AZ cap. So this is the value of what? This is the value of A bar cross B bar. But they are not asking A bar cross B bar here. They are asking the direction. Understood? Okay, so that means you have to determine what? You have to determine A n cap. So A n cap is equal to A bar cross B bar. What is A bar cross B bar? Minus AX cap plus 2 AY cap minus AZ cap divided by what? Magnitude of A bar cross B bar, that is square root of 1 square plus 2 square plus 1 square, that is 6. Yes or no here? So this is the direction of the surface here. So the direction is always given by the unit vector. Yes or no? Remember that point. Okay. This is how you have to determine the direction of the surface. Okay. Is it clear here? Yes or no here? Is it clear? Okay. Okay. Good evening. Nitin Gupta. Hi. Good evening here. Good evening. Okay. So I hope this problem is clear here. So we will move on to last problem. Yeah, one problem I will tell. Okay. After that we will start coordinate system. So let us say A bar is equal to 2 AX cap plus 4 AY cap plus 5 AZ cap, and B bar is equal to K1, not K1 here, we can take, okay, B1 is equal to 1 AX cap plus K1 AY cap plus K2 AZ cap, then determine the values of K1 and K2, and also determine and also determine the relation, determine the relation between K1 and K2, K1 and K2. Understood? Okay. So what they have given here? They have given two vectors A bar and B bar, and they are asking to determine the unknown values K1 and K2, K1 and K2, and also they are asking to determine the relation between K1 and K2. See, if you determine the values of K1 and K2, then you can easily get the relation between K1 and K2 or not? Yes or no? But here, how to determine these unknown values here? What we can do? Tell me. What we can do? Tell me here. What we can do? How to determine K1 and K2 values? What we have to do? Tell me here. Yes? Okay. See, now we know that whenever A bar and B bar both are parallel to one another, their cross product will become equal to what? Their cross product will become equal to 0. Yes or no? So if you do A bar cross B bar, if you do A bar cross B bar and equate it equal to 0, equate it equal to 0. Okay. So then wait, sorry here, wait. I have to give that statement here, sorry here. I have to give that statement A bar equal to this, B bar equal to this one, then determine the values of K1 and K2 and also determine the relation between K1 and K2, wait here, sorry, I have to give this relation. If A bar and B bar, if A bar and B bar are parallel to one another, so I forgot to give this statement here. Okay. So you have to consider A bar and B bar. If A bar and B bar are parallel to one another, then you have to determine the values of K1 and K2, and also you have to determine the relation between K1 and K2. Okay. Okay, yeah, fine. So since they have given that A bar and B bar are parallel to one another, which means A bar cross B bar, will be equal to what? Will be equal to 0. If both vectors are parallel to one another, then their cross product will become equal to 0. Understood? Okay. So now expand this here, A bar cross B bar, what you are going to get? So here AX cap, AY cap, AZ cap. Now 2, 4, 5, here 1, K1 and K2. So this must be equal to 0. Okay. So what you will get here? Tell me. So AX cap into 4K2 minus 5K1 minus AY cap into 2K2 minus 5 plus AZ cap into 2K1 minus 4. This must be equal to what? This must be equal to 0. See, whenever you are doing the cross product here, you are getting some vector quantity. That vector is having x component, y component and z component. Understood? So for this A bar cross B bar to become equal to 0, all this x component, y component and z component, all the three components must go to 0 or not? Yes or no here? All the three components must go to 0. Yes or no? Okay. So now equate it here. Equate each and every component to 0. So what you are going to get? Tell me. So 4K2 minus 5K1 is equal to 0. So from here you will get K2 is equal to 5 by 4 K1. K2 is equal to 5 by 4 K1. So this is the relation between K2 and K1. Understood? Next, equate this y component here, equate this y component to 0. So what you are going to get? 2K2 minus 5 is equal to 0. So K2 is equal to what? K2 is equal to 5 by 2, that is equal to 2.5. Understood? Next, similarly, equate this z component to 0 here. Equate this z component to 0. What you are going to get? 2K1 minus 4 is equal to 0. So K1 is equal to 4 by 2. So K1 is equal to what? K1 is equal to 2. K1 is equal to 2. Yes or no here? Okay. K2 is equal to 5 by 4 K1. Okay. Okay, so this is the relation between K2 and K1. This is the value of K2 and this is the value of K1 here. You can check these calculations here. You can check these calculations later. Okay, so I hope all are correct. Okay, okay. This is how you have to determine here. Understood? Okay, okay, fine. So these are some of the problems here. These are the some of the problems, few problems based on this cross product here, based on this cross product. Okay, so next, so with this we have completed the basics of vectors. Okay, so next we are going to start coordinate systems here. Next we will start coordinate systems. So next topic, coordinate systems. Next topic, coordinate systems here. Coordinate systems. See, in coordinate systems, we are going to study rectangular coordinate system. Its coordinates are x, y, and z. And then we are going to study cylindrical coordinate system. Its coordinates are rho, phi, and z. And then you are going to study spherical coordinate system. Its coordinates are r, theta, and phi. R, theta, and phi. So first of all, we have to understand why we have to study the coordinate systems. So what is the purpose? What is the purpose to study coordinate systems? See, the main purpose is, throughout our subject, we try to represent the field distributions here, like electric field distribution, magnetic field distribution, or electromagnetic waves distribution, yes or no, in three-dimensional space. So in order to represent those field distributions in three-dimensional space, okay, we can take the help of what? We can take the help of coordinate systems. So with the help of coordinate systems, we can easily represent the distribution of the fields, in three-dimensional space. Yes or no? If you are having some charge distribution, some static charge distribution, it is going to produce some electric field in its vicinity. We want to represent that electric field distribution. Okay, that we can represent with the help of these coordinate systems. Similarly, if you are having a current carrying wire, okay, so it is going to produce what? It is going to set up a B field. It is going to produce magnetic field in its vicinity. We want to represent that magnetic field in three-dimensional space, so that we can easily represent with the help of coordinate systems. And if you enter into antennas, there the antenna is going to radiate the electromagnetic waves. So these waves are going to distribute throughout the three-dimensional space. So we can easily represent the distribution of those fields with the help of what? With the help of coordinate systems. Understood? So without this, it is not that much easy for us to represent the field distribution in three-dimensional space. Understood? So that is the importance of this coordinate systems. Okay, okay. So now this coordinate systems here, okay, so these coordinate systems, we call them as what here? We call them as, we are going to follow this right-handed. These coordinate systems are called as right-handed orthogonal coordinate systems. Right-handed orthogonal coordinate systems. Understood? Okay. So why we are calling it as orthogonal here? Why we are calling it as orthogonal? Because if you consider rectangular coordinate system, these coordinates x, y, and z are mutually orthogonal to one another, or I can say mutually perpendicular to one another. And if you consider cylindrical coordinate system, these coordinates rho, phi, and z are mutually perpendicular to one another. Similarly, if you go for spherical coordinate system, this r, theta, and phi are mutually perpendicular to one another. So in all the three coordinate systems, all the three coordinates are mutually perpendicular to one another, and hence we are going to call this system as what here? Orthogonal coordinate system. We are going to call it as orthogonal coordinate system. Okay, so now comes the question, what do you mean by why we are calling it as right-handed? Why we are calling it as right-handed? Why means whenever we are drawing the coordinate axis here, we have to follow a convention. We have to follow a convention. That convention is nothing but right hand convention. That convention is nothing but right hand convention. So what do you mean by that right hand convention? We are going to see now. Okay, so what do you mean by right hand convention? So now here right hand convention I am giving in this table here. Here I am giving in this table. Okay. Suppose if you consider x-axis and y-axis, consider x-axis and y-axis. Okay. So I will explain here x, y, z. Okay, I'll wait. I'll explain. So x, y, z. So whenever we are drawing the coordinate axis here, you have to follow this right hand convention. So what this right hand convention will tell you is, see here, if you consider x-axis here, x-axis and y-axis. So let us assume this is x-axis here. I am drawing the x-axis here, and this is y-axis. Okay. So whenever you draw x-axis and y-axis here, now the direction of positive z, axis, it may be out of the board or it may be into the board. Yes or no? It is having two possibilities. Yes or no? So z axis must be perpendicular to both x axis and y axis. That means I can take this positive z axis either out of the board or I can take it as into the board. So in which direction you have to consider? You have to consider either out of the board direction or you have to consider into the board direction. Which one you have to consider? So that is given by this right hand convention. So what it tells you is, if you enclose the right hand four fingers, from x to y, then the thumb is going to give you the third positive coordinate. Okay, the third positive coordinate direction. Understood? Okay. So now here this is x-axis and y-axis. So take your right hand. You have to enclose the four fingers of your right hand from where to where? From x to y. So if you enclose your four fingers from x to y, the thumb is pointing in which direction here? Out of the board. So that means in this case you have to consider the third positive coordinate, that is z-axis, out of the board. You have to draw always this z-axis out of the board in this case. Understood? Okay. Now similarly if I consider this as, let us say this is y-axis, okay, and this is x-axis. Let us say this is x-axis. Now tell me, what is the direction of positive z-axis here? What is the direction of positive z-axis? Tell me here. Tell me. See here. I hope you know this convention here. Yes or no? See, if you represent a dot and encircle this dot with a circle, if you enclose this dot with a circle, it represents the vector that is coming out of the board. Yes or no? So if you draw a circle and inside that circle if you put into mark, then it represents a vector that is pointing into the board. Yes or no? See, why we have taken this symbols means, see here, if you are having a vector here, so if I throw the arrow towards you, you are going to see this tip of the arrow. Yes or no? That means you are going to see the dot. Yes or no? So this represents the vector is coming out of the board. So if you throw the arrow into the board here, then you are going to see this cross mark. Yes or no? You are going to see this cross mark. That means whenever the vector is moving into the board, you are going to see this cross mark. When our vector is coming out of the board, you are going to see the tip of the arrow. Understood? It just looks like dot. Okay. So if you put dot and encircle if you close this dot with a circle, okay, it represents the vector that is pointing out of the board, and if you put into mark and if you enclose this with a circle, it represents the vector that is going into the board. Understood? Here z-axis is coming out of the board. Now in this case tell me whether positive z-axis has to come out of the board or into the board. Tell me here in this case. Tell me here. Yes, definitely here, definitely. I will note down the points also. Okay. Now tell me the answer for this one. Tell me. Tell me the answer for this one. Positive z-axis has to point out of the board or into the board in this case. Tell me here. Positive z-axis has to point out of the board or into the board in this case. Now whenever you are having x-axis and y-axis, you have to, what I said, you have to follow always right hand convention. So you have to curl your 4 fingers of your right hand from where to where? From x to y. From x to y. So if you curl your 4 fingers from x to y, the z-axis is pointing out of the board. Yes or no? So that means here z-axis has to come out of the board. Now I will give one more example here. Few more examples. You have to tell me the answer. Okay. See. Third one here. Let us consider here. Let us say this is y-axis. Here. And this is z-axis. Tell me the direction of positive x. It is out of the board or into the board? Tell me here. Tell me. In this case, positive x-axis will come out of the board or into the board? Tell me. Next, in this case, let us consider this as z-axis and this as x-axis. So in this case, tell me what is the direction of positive y. In this case, what is the direction of positive y? And in this case, tell me the direction of positive x. Tell me here. So always you have to follow what? You have to follow this right hand convention. Now here you are having y-axis and z-axis. So you have to curl your right hand fingers from y to z. Yes or no? So if you curl your fingers from y to z, take your right hand, curl your 4 fingers from y to z, then the thumb is pointing out of the board. So that means here positive x-axis has to point out of the board. Yes or no? Now tell me in this case here. Tell me. Now here you are having z and x. So you have to curl your right hand fingers from where to where? From z to x. Yes or no? From z to x. Understood? So if you curl your fingers from z to x, then thumb is pointing into the board. So in this case, the positive y-axis is going to point into the board. Understood? So this is how we have to draw the coordinate axis. Yes or no? So whenever you are drawing the coordinate axis, you have to follow what here? You have to follow right hand convention. Understood? So always remember this one here. This will give you the right hand convention. This table will give you the right hand convention. Understood? Okay. You can take any 2 coordinate axis as you wish here. In order to determine the third positive coordinate, you can simply use this right hand convention. Understood? You always follow this right hand convention whenever you are drawing the coordinate axis. Understood? Okay. So if you miss this one, you are going to do wrong whenever you are solving the problems here. Whenever you are solving the problems also, you have to follow the same convention throughout the subject. Understood? Okay. Okay. Yeah. So that's why all these coordinate systems are called as what here? Right hand orthogonal coordinate systems. Right-handed orthogonal coordinate systems. Whenever you are drawing the coordinate axis, you have to follow the right hand convention. Since all the 3 coordinates are mutually perpendicular to one another, we are calling it as orthogonal. Understood? Okay. Okay. Yeah. So we will start. Next, we will start with first rectangular coordinate system here. Rectangular coordinate system. So the first coordinate system is rectangular coordinate system. X comma y comma z are the coordinates. So let me know, is it clear here up till now? Is it clear? Okay. Okay. So next we will start with a rectangular coordinate system. Okay. So now here I am drawing the coordinate axis here. So let us say what here? Okay. So Okay, so this is one axis and this is another. Okay, okay. So this is x-axis I am considering, this is y-axis. So if you curl your right hand fingers from x to y, z-axis has to point upward direction. So this is z-axis, this is z-axis. Understood? Okay. Okay. Yeah. So now here the reference point here is nothing but origin. I am considering the reference point as what here? Origin. So here this origin is nothing but 0, 0, 0, 0, 0, 0. So this is the reference point. Okay. Now here I am considering a point in three-dimensional space. I am considering a point in three-dimensional space. So that point I am representing as x, y, z here. This point I am representing as x, y, z. So somewhere in three-dimensional space I have considered a point. That point is nothing but x, y, z. X, y, z. Okay. So now see here. Now, if I draw a vector here, that is pointing from the origin, from origin to this point, okay. So if I draw a vector that is pointing from origin to this point, so this vector I am naming it as r bar. This vector I am naming it as what here? R bar. Now if you observe this r bar here, this r bar is neither along x nor along y nor along z. Yes or no? So this r bar is having its components along those reference axis or not? Yes or no? In the previous class what I have said here, whenever you are having a vector which is neither along our reference axis, then it is going to have its components, along those reference axis. Yes or no? So in the previous session I have given this point clearly. Understood? Okay. Okay. So this r bar is neither along x nor along y nor along z, and hence it is having all the three components, that is x component, y component and z component. Now how to get the x component, y component and z component here? We know how to determine the component. Yes or no? What we have to do? Just drop your normal here. Just drop your normal from the head of r bar, onto xy plane. So now the normal distance from the x-axis to this point, will give you what? Will give you the y component. And the normal distance from the y-axis to this point will give you what? Will give you the x component. And the distance from here to here, will give you what? Will give you the z component. Understood? So this r bar is having all the three components, x component, y component and z component. Understood? Okay. Now this r bar we call it as position vector here. We call it as what here? Position vector. This r bar we call it as position vector. So what do you mean by position vector here? Why we are calling it as position vector? If I consider some point here, let us say x1, y1, z1. Okay, so then the vector that is pointing from origin, to this point, I am calling it as r1 bar. Now if I consider some other point here, let us say this point is x2, y2, z2. Now the vector that is pointing from this origin to this point, I can call it as what? I can call it as r2 bar. So here r1 bar, r bar, r2 bar, all are nothing but what? Position vectors only. So what they are saying here, what is the significance of this position vector? The position vector is going to give you the position of any point, in three-dimensional space with respect to what? With respect to origin. That is the purpose of position vector. What is the purpose of position vector here? It is going to give you it is going to give you the position, it is going to give you the position of any point, the position of any point in three-dimensional space, in 3D space, with respect to what? With respect to origin, with respect to origin. Yes or no? So that's why we call it as what? That's why we call it as position vector. That's why we call it as position vector. Understood? So it always gives you what here? The position of any point in three-dimensional space with respect to origin. So that's why we call it as position vector. Position vector. Understood? Okay. Okay. Now now see here. Okay. Okay. Now one more point I want to explain about this position vector. See here. Now if we know the angle here, if we know the angle made by r bar, made by this position vector with x-axis, let us say you know the angle made by r bar with x-axis, let us say you consider that as phi x, let us say that is phi x. Now if we know the angle made by r bar with respect to y-axis, with respect to y-axis, let us consider that as phi y. Okay, or instead of this you can take alpha, beta, gamma here. That is simple. Every time you have to write phi x, phi y. Okay, so instead of that you can consider here this is alpha, that is the angle made by r bar with respect to x-axis, and here you consider beta, this is the angle made by r bar with respect to y-axis, and this is gamma, this is gamma as the angle, gamma is the angle made by r bar with z-axis, with z-axis. Now if we know the angles made by the position vector, if we know the angles made by position vector with respect to our reference axis, with respect to our reference axis, then you can represent this r bar in terms of what? In terms of alpha, beta and gamma, alpha, beta and gamma. Yes or no here? See, what is r bar here? What is r bar? Tell me. See here, r bar. Okay, so r bar is equal to, how you can write r bar? Tell me. See, it is the vector that is pointing from where to where? From origin to this point x comma y comma z. So how to represent this r bar vector here? So as you move from this point to this point here, as you move from origin to this point, okay, so the increment in x, is going to give you the x component, and the increment in y is going to give you the y component, the increment in z is going to give you the z component. So as you move from the tail of the vector to the head of vector, what is the increment in x? That is going to give you x component. What is the increment in y? That is going to give you y component. What is the increment in z? That is going to give you z component. So what is the increment in x here? Tell me. So x into ax cap. Yes or no? Next, what is the increment in y? That is y minus 0. So you are going to get y into ay cap. What is the increment in z here? Z minus 0. So that is z into az cap, z into az cap. Understood? Okay, so this is how you can represent the vector. So this is one manner, this is one manner. Understood? Now if you know the angles here, if we know the angles, then how to represent this vector? How to represent this vector? See here, this is nothing but x component, y component and z component. See, we have already studied how to determine the component of one vector along the other. Yes or no? So this is the component. This is nothing but the component of r bar, the component of r bar along x direction or not? Yes or no? And this y is nothing but the component of r bar along y direction, and this z is nothing but the component of r bar along z direction. So how you can write the component of one vector along the other here? See, if you want the component of r bar, along x direction, what you have to do? Take r bar and do the dot product with what? And do the dot product with ax cap. So what you are going to get? Tell me. So you are going to get r into cos alpha or not? Yes or no here? Magnitude of r bar, okay, magnitude of ax cap is 1 multiplied by cos alpha, where alpha is the angle between r bar and x axis. Similarly, if you want to determine the component of r bar along y, what you have to do? So r bar dot what? R bar dot ay cap, that is equal to what? That is equal to, you will get r into cos beta, where beta is the angle between r bar and y axis. Similarly, if you want the component of r bar along z axis, then you have to do r bar dot az cap, that is going to give you what? That is going to give you r into cos gamma, r into cos gamma. Yes or no here? Okay. So now see here. Okay, now here I can write r bar is equal to, okay, so this is nothing but x component, this is nothing but x component, that means this is x value. Yes or no? This is nothing but y component, that is this y value. This is nothing but z component, that means that z value. Understood? Now substitute this x value in terms of r cos alpha, y value in terms of r cos beta, z value in terms of r cos gamma in this expression. So what you are going to get, tell me? So you are going to get r cos alpha ax cap, yes or no, plus r cos beta ay cap plus r cos gamma az cap. Yes or no? So this is r bar, this is r bar. Now see here, now what I can take common here from all these three components, what I can take common? I can take r common or not? Yes or no? So if you take r common and take that r to LHS side here, what you are going to get? You are going to get r bar divided by r. So r bar divided by r is equal to cos alpha ax cap plus cos beta ay cap plus cos gamma az cap. Yes or no? So now we got one beautiful result here. So what is this r bar by r here? Vector divided by its magnitude. Yes or no? Vector divided by its magnitude will give you what? Will give you the unit vector. Yes or no? So this is nothing but the unit vector along what? Along r bar. So you can represent the unit vector along r bar as what here? Cos alpha ax cap plus cos beta ay cap cos gamma az cap, cos gamma az cap. So we know that always the unit vector is going to give you what? Is going to give you the direction. Is going to give you the direction. So we have represented the direction of a vector. We have represented the direction of a vector in terms of what? In terms of cosines. In terms of cosines. And hence this cos alpha, cos beta, cos gamma are called as direction of cosines here. These are called as what here? Direction of cosines. Why we are calling them as direction of cosines here? Because we are representing the direction of the vector. We are representing the direction of the vector in terms of what? In terms of cosines. Yes or no? So that's why it is called as direction of cosines. That's why it is called as direction of cosines. Understood? Okay. So is it clear here? Is it clear? Okay. So that's why we call it as direction of cosines. Now here, okay. So now here we got here AR cap is equal to cos alpha AX cap plus cos beta AY cap plus cos gamma AZ cap. Now, what is the magnitude of AR cap here? Magnitude of AR cap must be equal to what? Must be equal to 1 because it is unit vector. Yes or no? So, what is the magnitude of this AR cap here? So, the magnitude is nothing but what? Square root of cos square alpha plus cos square beta plus cos square gamma plus cos square gamma is equal to what? Is equal to 1. So if you square on both sides here, if you square on both sides, what you are going to get? You are going to get one condition, that is cos square alpha plus cos square beta plus cos square gamma is equal to what? Is equal to 1. Is equal to 1. Okay. So cos square alpha plus cos square beta plus cos square gamma is always equal to what? Is always equal to 1. Understood? So is it clear here up till now? Tell me here, is it clear? Yes or no? So this is about direction of cosines here. This is about direction of cosines. Okay. So cos square alpha plus cos square beta plus cos square gamma is equal to 1. Is equal to 1. Understood? Okay, fine. Next. Next, here what is important? What is important in all the three coordinate systems? What is important in all the three coordinate systems is differential lengths, differential areas and differential volume here. Differential lengths, differential areas and differential volume. So these three things are very, very important in all the three coordinate systems. So these are going to be very much helpful for us to learn the subject here. Okay. So we are going to concentrate on this here. So here let us say this is x-axis and this is y-axis and this is z-axis. This is z-axis. Understood? X-axis, y-axis and z-axis. Now if I consider a small differential length, along x here, if I consider a small differential length along x, I can represent it as what here? I can represent it as dx. Yes or no? If I consider a small differential length along x, I can represent it as dx, and it is pointing in which direction here? X direction. So I have to represent the direction, that is dx ax cap. So that means in the three-dimensional space here, if you consider a small differential vector, that is parallel to what? That is parallel to x-axis. You can consider it as what? You can consider it as dx ax cap. So in three-dimensional space, wherever you write a small differential length here, wherever you draw a small differential length that is parallel to what? That is parallel to x-axis, you can consider it as what? You can consider it as dx ax cap. Understood? Now similarly, if you consider a small differential length, along y here, so you can represent this as what? Dy ay cap. So any vector, any small differential vector that is parallel to y-axis, you can treat them as what? Dy ay cap. Understood? Similarly, if you consider a small differential vector, along z-axis, I can consider it as dz az cap. So any small differential vector that is parallel to z-axis, I can treat them as dz az cap. Understood? So these are the small differential lengths. Along x, y and z. Understood? So what are the differential lengths that we are having in a rectangular coordinate system here? The three differential lengths. What are they? That is nothing but dx ax cap, dy ay cap and dz az cap. So these are the three differential lengths we are having in rectangular coordinate system. Now if I consider a small differential length, neither along x nor along y nor along z. So if I consider some small differential length dl bar here, so now this dl bar is neither along x nor along y nor along z. So that means this differential length is going to have what? Is going to have its components along what? Along x, y and z. So you can represent that dl bar here. dl bar is going to have its differential component along x. So the differential component along x is nothing but what? Dx ax cap, and its differential component along y, that is nothing but dy ay cap, and its differential component along z, that is nothing but dz az cap. See, we are utilizing all the properties here, whatever we have studied. Yes or no? We are utilizing all the properties. Yes or no? So if dl bar is neither along our reference axis, it is going to have its components along those reference axis. Yes or no? So now here this dl bar is going to have its differential component along x, that is dx, the differential component along y, that is dy, the differential component along z, that is dz. Understood? So this is differential length here, Now here, okay. Now here tell me with dx ax cap, dy ay cap and dz az cap, with dx ax cap, dy ay cap, dz az cap, we are having three differential lengths. So with the help of these three differential lengths, how many differential areas you can form here? Tell me. With the help of these three differential lengths, how many differential areas you can form? See, just now we have seen, in order to get the surface area, in order to get the area, what you have to do? You have to do the cross product between any two vectors. So the cross product between any two vectors is going to give you what? Is going to give you the area. Is going to give you the area formed by those two vectors. Yes or no? Now here you are having dx ax cap, dy ay cap, dz ay cap. So totally we are having three differential lengths. Yes or no? So if you do the cross product between any two differential lengths, that is going to give you what? That is going to give you one differential area. So in that manner, since we are having three differential lengths, how many differential areas you can form here? Tell me. With the help of any two differential lengths, you can form one differential area. So in that manner, you are having three differential lengths. So with the help of these three differential lengths, how many differential areas you can form here? Tell me here. How many differential areas you can form? Three or not? Yes or no? So what are they here? What are they? So first you have to take dx ax cap and dy ay cap. If you do the cross product between these two, you are going to get a small differential area formed by dx and dy. Yes or no? Okay, so I am representing that with dA1 bar. dA1 bar is equal to what? Is equal to dx ax cap cross what? Cross dy ay cap, dy ay cap. So this is going to give you what? It is equal to dx dy. Now here ax cap cross ay cap, ax cap cross ay cap must be equal to what? Must be equal to az cap. Yes or no? So now ax cap cross ay cap is nothing but az cap. Now if you observe this dx dy is the small differential area in xy plane or not? Yes or no? Dx dy is nothing but the small differential area in xy plane. And I said for any surface, the direction of the surface is given by what? Is given by the unit normal drawn to that surface. Since this dx and dy are present in xy plane, if you draw the unit normal to that xy plane, it is going to point in which direction? Az cap direction or not? Yes or no here? So this is the magnitude of the small differential surface area formed in xy plane. And this is the direction of what? This is the direction of this small differential surface area in xy plane. Yes or no here? Now here one more thing we can observe here is, here what are the variables here in xy plane? In xy plane what are the variables? X is variable and y is variable. That means z is constant or not? Z is constant or not? So we can call this area as z is equal to what? Z is equal to constant plane. We can call this as what? Z is equal to constant plane. Why are? Because in this plane x and y are variables, z is constant. So hence we can call this plane as what here? Z is equal to constant plane. And one more point here you have to observe is this z equal to, for z equal to constant plane, the direction is along what? For z equal to constant plane, the direction is along az cap. Yes or no here? The direction of z equal to constant plane will be along what? Will be along az cap. Yes or no? See, if you draw x-axis here, y-axis here, z-axis here. Understood? So if you consider a small differential area in this xy plane, so this is dx and this is dy. So if you draw the normal to this one, it is going to point along az cap direction. Understood? Okay, so this small differential area is present in xy plane, so we can call it as what? This is nothing but z is equal to constant plane. So for z equal to constant plane, the direction is what? The direction is along az cap direction. Understood? Okay. Okay, yeah. So this is the small differential area we got. Now, if you want the total surface area here, if you want the total surface area formed by the ranges of x and y. Now, for example, if suppose if I have given x is varying from x1 to x2 and y is varying from y1 to y2, then what is the total surface area here? What is the total surface area? So, what you have to do, if you want the total surface area here, if you want the total surface area, what you have to do? So, here how many variables you are having? 2 variables or not? Yes or no? So, you have to integrate with respect to these 2 variables over their ranges, yes or no? So, you have to integrate with respect to x, and also you have to integrate with respect to what? With respect to y. So, here you have to put the ranges of x and the range of y. So, this is going to give you what? This is going to give you the total surface area formed by what? Formed by these variables x and y over the ranges x1, x2 and y1, y2. So, here x is varying from x1 to x2, y is varying from y1 to y2. So, if you do this, I forgot to mention the direction here. Direction is AZ cap. Okay. So, if you do this, you can write directly here what you are going to get. You are going to get x2 minus x1 into y2 minus y1 AZ cap. So, this is the total surface area formed within the formed by the ranges of x and y. Yes or no? Now, what is the shape of this surface here? What is the shape of this surface? So, this is just looking like what? This is, let us say this is x1. Okay, wait. So, if I consider this as x axis, y axis, okay. So, this point is x1 and this is x2, and let us say this is y1, this is y2. Understood? So, the distance from here to here is nothing but x2 minus x1. So, from here to here it is nothing but y2 minus y1. So, if you multiply these two, you are going to get this surface area. Understood? So, the shape of the surface, you are getting what? You are getting a rectangle. Yes or no? So, the shape of the surface is nothing but what? Is nothing but a rectangle. And the direction of the surface, this is called as z equal to constant plane. For z equal to constant plane, the direction of the surface is along AZ cap direction. Understood here? Okay. Is it clear? Tell me here, is it clear? Yes or no? Okay. So, now similarly we are having dy ay cap and dz az cap. Okay. So, another differential area you can form. So, all the differential lengths are dx ax cap, dy ay cap, dz az cap. So, we have formed the differential area formed by dx and dy. Next, you can take dy and dz. So, dA2 bar is equal to what? So, dy ay cap cross dz az cap. So, this is going to give you what? This is nothing but dy dz ay cap cross az cap is nothing but what? Is nothing but ax cap. So, now here the variables are y and z. Here the variables are y and z. What is constant here? X is constant. So, you can call it as what? You can call it as x is equal to constant plane. X is equal to constant plane. So, the direction of x equal to constant plane is going to point along which direction? Ax cap direction. Yes or no? Now, if you want the total surface area here, then what you have to do? You have to integrate with respect to y and z. So, integrate with respect to y and z here. So, dy dz ax cap. Understood? So, what you are going to get? If you do this, if you substitute some range for y and some range for z, okay, you are going to get what? You are going to get a rectangle. Here also you are going to get the shape is nothing but what? The shape of the surface you are going to get as rectangle. Yes or no? Now, similarly dA3 bar is equal to with dz az cap and dx ax cap. So, if you multiply these two, that means if you do the cross product between these two, what you are going to get? dz az cap cross dx ax cap. Okay. So, what you will get here? Tell me. So, you will get dz dx into what? Into ay cap. Az cap cross ax cap is nothing but ay cap. Here z and x are variables, y is constant, so we can call this plane as what? Y is equal to constant plane. Y equal to constant plane. So for y equal to constant plane, its direction is along ay cap direction. Its direction is along ay cap direction. Now here also, if you try to determine the surface area, if you try to determine the total surface area, okay, what you are going to get here? Here also you are going to get rectangle or not? Yes or no? The same thing here. So A3 is equal to what? You have to integrate with respect to two variables, that is with respect to z and with respect to x. So dz dx ay cap. So if you substitute some range for z and some range for x, you are going to get the shape of what? The shape of rectangle. The shape of rectangle. So that means all the three surfaces here, all the three surfaces that we are going to get in rectangular coordinate system are nothing but what? Are nothing but rectangles. Yes or no? Are nothing but rectangles. All the three surfaces. We got three surfaces or not? Yes or no? So one is in xy plane and another one is in yz plane and another one is what? Another one is in zx plane. So all the three surfaces are of the shape what? Are of the shape rectangle. Yes or no here? All the three surfaces are of the shape rectangle. Okay, so that's why we have named it as rectangular coordinate system. Rectangular coordinate system. Understood? Okay. Okay, yeah. So now, okay, we have determined the differential areas. Now tell me, how to determine the differential volume here? How to determine the differential volume? See, if we know differential lengths here, then you can determine differential areas and differential volume very easily here, very easily. So these are the three differential lengths you are having. Now in order to form the volume here, what you need here? What you have to do? Tell me here. In order to get the differential volume, what you have to do? What you have to do here? How you can form the volume? You are having three differential lengths. What you have to do in order to get the volume? Volume, how you can get? Length into breadth into height, yes or no? So you need three differential lengths in order to form what? In order to form the volume. Understood? So here we can form one volume. So what is that volume? How you can form the volume? See here. See, the mathematical procedures you know here, but I want to make the interpretation of that mathematics. Understood? So that is very important here. That interpretation is very important. Now here, if I consider a small differential area, I am considering a small differential area like this. Understood? So let us say this is dx and this is nothing but dy. So this is the small differential area dx dy. So in xy plane. Understood? Now if you, the direction of the surface is along what? Along az cap direction. Now here z direction, z is pointing out of the board. Z axis is pointing out of the board. Yes or no? So the direction of this surface is along positive z direction, dx into dy. Understood? Okay. Wait here. Okay. So now if you extend this surface here, if you extend this small differential surface, okay, if you extend this small differential area in z direction, in positive z direction by dz units, if you extend this small differential area along z direction by dz units, what you are going to get? You are going to get the volume or not? Yes or no? So take this small differential area and extend this small differential area along what? Along its perpendicular direction. Along its perpendicular direction means along z direction. So if you extend this surface area along its perpendicular direction, you are going to get what? You are going to get this volume. You are going to get this volume. So from here to here, it is nothing but dz units. So take the surface here, take the small differential surface and extend that surface along its perpendicular direction by dz units along z direction. Then you are going to get what? You are going to get the differential volume. Yes or no? Similarly, you can take any small differential area in zx plane. You can take any small differential area in zx plane. If you extend this surface along its perpendicular direction, you are going to get what? You are going to get the differential volume. Similarly, you can consider any small differential area in yz plane, and if you extend that surface along x direction, you are going to get what? You are going to get the differential volume. Yes or no? Okay, so take any surface and extend that surface along its perpendicular direction, you are going to get what? You are going to get the volume. Yes or no? Okay, so now here that's what we are going to do here. So differential volume, how you can determine? So take any surface area. So let us consider dx ax cap cross dy ay cap. So this is the small differential area in xy plane. So now you want to extend this surface here. You want to extend this surface along which direction? Along its perpendicular direction. What is its perpendicular direction? Is nothing but az cap. So how many units you want to extend? By dz units. So dz az cap. So here if you do dx ax cap cross dy ay cap. Okay, wait. I am writing here, yeah. Okay, so here you will get dx dy ax cap cross ay cap is az cap. Understood? So you want to extend this surface by dz units along az cap direction. Now here you have to do, this is a vector, this is also a vector. Now you have to do cross product or dot product here in order to get the differential volume. Tell me. You want to extend the surface along z direction by dz units. So here you have to do the cross product or dot product in order to get the differential volume. Tell me, respond here. What you have to do? See, if you do the cross product here, az cap cross az cap will become what? Will become 0. So you don't get any volume. So what you have to do? You have to do the dot product in order to get what? In order to get the differential volume. Yes or no? So now here dv is equal to what here? dv is equal to dx dy az cap dot az cap will become 1. So you will get dx dy dz. So now here this volume, this differential volume is the resultant of what? Is the resultant of this dot product or not? It is the resultant of this dot product. So that means it is nothing but what? The resultant of dot product is nothing but what? Is nothing but a scalar quantity. So that's what we have said here. Surface area is a vector quantity, whereas volume is a scalar quantity. Yes or no? Okay, so now if you want the total volume here, how to determine here? So now here you are having 3 variables here. Now here you are having 3 variables. So you have to integrate with respect to those 3 variables in order to get the total volume. So you have to integrate with respect to x, integrate with respect to y, integrate with respect to z. So dx, dy, dz. This is going to give you the volume. Now, what is the shape of this volume here? What is the shape of this volume you are going to get? You are going to get what? You are going to get the shape as what? The shape is nothing but cube. Yes or no? You are going to get the shape of the volume as cube. Yes or no? Okay. So it is very simple to visualize here. Yes or no? Okay. So you are going to get the total volume as cube in rectangular coordinate system. Understood? So this is all about how to determine the surface area and how to determine the volume. Okay, volume is a scalar quantity, we have proved that, and surface area is a vector quantity. Understood? Okay, so is it clear here up till now? Respond here. Is it clear? Up till now, is it clear here? Okay. So this is all about this rectangular coordinate system here. This is all about this rectangular coordinate system. So in the next class, we are going to start cylindrical coordinate system here. We are going to start cylindrical coordinate system in the next session. So I am winding up this session now. Okay. So let me see the comments here. Yeah, I don't understand Hindi. Yaar. Somebody is giving a comment in Hindi. Okay. Okay. So with this, I'm winding up this session here. So in the next class, we are going to start the cylindrical coordinate system. So I hope up till now it is clear here. I hope it is clear up till now. Okay. So thank you here. Bye bye. Take care. So we'll meet in the next class. Okay. Bye bye.